You want to know exactly at every minute what is the condition of your switch. And if you see there might be a breakdown, you want to send out service teams in advance. And there might be some switches which are very stable and work very good. I rather take it and already put my resources on a switch where I see this might have problems in the next 3 months.
Welcome to FNet Silica's We Talk IoT. We'll chat with innovators, experts and business owners to learn how they are implementing IoT and using data to create new business opportunities. I am your host, Stephanie Ruth-Hader. Today, we are diving into a critical piece of infrastructure that millions depend on daily: railway systems. Our guest today is Oliver von Sperber, Managing Director at AXO Track, a German company revolutionizing how railway operators maintain their complete switch infrastructure. And I learned from you in our briefing call that 20% of train delays stem from these switch malfunctions. And they cost operators millions and they frustrate passengers worldwide. So you and your team at AXO Track address this challenge through IoT sensors and predictive maintenance technology. You monitor railway switches in real time, detecting problems before they cause expensive breakdowns and passenger delays. Oliver brings unique expertise to this challenge. He founded AXO Track after running a mid-market investment bank and a sensor technology company. He even completed training as a railway switch mechanic to understand all the technical details involved. So I'm really excited to have you on the show today, Oliver. Thank you so much for being here.
Thanks for having me.
Oliver, welcome to We Talk IoT. Tell us about AXO Track and what problem you're solving in the railway industry.
Well, AXO is a startup company founded 2022. And actually, I was sitting in a train and it had a delay. And they said it's because of a malfunction of switch and crossings. In German, you say Weichenstörung.
Yeah.
And I was just curious to find out what is this thing with the Weichenstörung. And this is when it struck me. I saw that 20% of all train delays are caused by malfunction of switch and crossings. And this is not only in Germany, it's global. It's a global problem. It's all over the place. And so I thought, yeah, let's find it out what's going on. And I booked this switch technician course.
Okay.
And there I learned that what can break, and these things are getting measured, but they don't getting measured permanently.
Okay, wow.
So people go out on the track in certain intervals, and then the maintenance the switches in manually, but what happens in between the intervals, they are blind. And this is exactly what we are doing. We mounting sensor systems on the critical parts of a switch to see what's going on and send out service teams before there's a breakdown.
Why are these switches so prone to failure? Why are they so sensitive? They are a very important piece of the track.
The switches are one of the most critical infrastructure or parts of the infrastructure. And it's a part which wears and tears over time.
Okay.
Because, the wheel sets of a train jump basically from one rail to the next. And this has enormous forces. This has enormous impacts. So it's all about the perfect geometry of the switch. So the transition from one wheel set, from one track to the other is very smooth.
Okay. Yeah, I just remember it from the model trains. The little trains derailed always when you try to switch the tracks too fast and then everything flew out in one corner, right? So I imagine there's lots of weight, there's lots of force, and there's lots of friction going on. So is that why they're so sensitive?
Yes, it's of course, the faster the train, the more force is on it, or the heavier the train. And basically the whole track system, the system to bring vibration in the ground. So you have the train, steel on steel, this vibrates, and the vibration goes through the sleepers, through the gravel into the ground.
Okay.
And this gravel it's really sharp gravel, and it starts to deteriorate. And then the whole system starts to move. And this gets stronger and stronger by time. And you have to detect when there's a point of no return and do maintenance before this happens.
And in the course you took, what did you learn? And is it that where you thought about what company you want to build and what product you want to make?
Yes, exactly. I really was curious and was wondering, why are you not measuring this? And there are some parts which are getting measured, but other parts which nobody cares about it. And this is where I said, okay, let's try, let's have a look. And I discussed this problem with specialists at Deutsche Bahn and said, this is something you have to develop on the track. And when I get a pilot track to develop this, was the moment where I said, okay, makes sense. I'm founding AXO.
Fascinating. Before we dive into your sensor technology and what it is that you do,
Yes.
No one ever thought about this before.
No, there are solutions in the market to measure it, but not on all critical parts. And this is basically due to development of sensor technology.
Okay.
So you always, in a way, could measure it, but to bring out a sensor system which is permanently on the track and can resist this very strong demands, heat, coolness, this forces which a train brings in, is difficult and would have been very expensive. And only recently, through the development of the smartphone or through the smartphone industry and the development of the sensor technology, the technology is price-wise so cheap that you can employ technologies permanently on the track.
Okay. What do you mean by permanently? Is it like a box?
It's always there.
Is it like...
It's always there, autark, in the best way, without having any power source driven by batteries or solar cells. Why solar cells are very difficult on the track because of the dirt. And then, of course, you don't want to change batteries every 6 months. So it should run for years, because you cannot just go on the track. You know, if there's an ICE coming by with over 160 kilometers per hour, you don't want to be anywhere near.
Yeah, I imagine. So how does your IoT sensor technology work? What parameters are you monitoring on these switches?
We are monitoring mainly vibrations, but also temperature and humidity.
And this helps you then analyze kind of the health of the switch?
Exactly. You can really see every wheel set. So we can even identify through the patterns exactly which train is going over the track, in which speed, and so on. And there you can really see what is the impact on the track and on the switch.
Interesting. I suppose you can also then loop that back and make deductions that what maybe trains need to look like in the future to help sustain critical infrastructure. Or is that too far?
I think that the rolling stock, how they say, that the trains, so it's basically the railway industry is divided perhaps in this rolling stock and the infrastructure. And we are more on the infrastructure side. And the rolling stock side already for many years have a lot of IoT systems in place, and the infrastructure science lags a little bit behind.
Okay, I understand. Tell us about the technical challenges of deploying these sensors. You just mentioned dust and vibrations. Railway infrastructure operates in extreme conditions, and especially in Europe, where you have then also different seasons. I suppose in southern countries, it's more heat-related problems. In northern countries, it's more frost or cold-related problems. How do you ensure reliable data connection?
I think the data connection is ensured by 5G network, a cellular network. So we send the data over the 5G network. But of course, you need to, you can send, so if one train passes the switch, you have 100,000 of data points. And it makes no sense to send 100,000 of data points for example, to Deutsche Bahn. What are they doing with this? So you have to have an interpretation algorithm, and to keep the battery spending very low, you interpret this data already on the embedded system and then just send the results.
Oh, interesting. So basically the system collects the raw sensor data and then turns it into actionable insights for the maintenance teams already on the track.
Exactly. Yes, we can ask the system either send raw data or send results. But in, let's say, in permanent use, they're just sending results, of course.
Sounds great. And to circle back, you mentioned that smartphone technology or the evolution of the smartphone technology helped accelerate your innovation. What other factors have made IoT-based railway monitoring possible now?
I think there's no other way than to look into digitalization of the railway network. You see, Deutsche Bahn wants to double passengers until 2030, and this is also really the political will. You have the Green Deal, which says we want to reduce CO2 emissions until 2050 by 30%. And if you want to do this in the transport sector, you need to shift traffic from the plane to the rail, from the street to the rail. And you cannot just double the infrastructure. In a way, we have a good infrastructure, but this means you need more trains on the tracks in a higher frequency and perhaps also with higher speed. And this increases the stress on the infrastructure, which is, as probably everybody knows, anyway already old. Then at the same time, you have a shortage of skilled workers. So you have very experienced, very motivated workers, but a lot of them are going, they're going to retire, and you don't get enough young people. If you increase the stress on the tracks, you also need to maintain this more. To maintain the track, you need pauses where the trains can't go. If you increase the frequency of the trains, you have less pauses to go. So there is a strong need to go in digitalization and doing this. At the same time, it's a very regulated market because it's all about, in the infrastructure, it's all about safety. Yeah. You want to avoid accidents. So this is why you have rules where track workers go out in certain intervals and go step by step, which is also right to do this. And the rate of accidents in Germany is very, very low. So this is always the first priority, avoid accidents. You have to shift this rule. And this takes time, of course, to shift rules, because you have long trial phases where you see, okay, we are sure that in certain ways, sensor technology can take over the view of a railway technician or even improve it.
And the issues you mentioned, older infrastructure, lack of investments, I suppose, shortages of skilled workers. That, of course, Germany is a good example, obviously, since this is where you started the company. But this goes, I think, for most of the European system, right? For France as well, for the UK. I wonder if, I always think that in Japan, the trains are supposed to be really modern and fast and digitalized. Can you tell us a little bit about the market in Europe? And maybe where and the inspiration you're getting from other areas in the world?
So in Japan, they have different trains. They have also different materials on the switch and crossing, so it's
really?
Slightly different problems.
Interesting.
But they still have this. Problem. So we're also in discussion with Japanese switch manufacturers.
Oh, cool. Okay.
It's actually quite interesting. But in general, you need, so the railway infrastructure, so the average age of switches in Germany is over 20 years. And this is also okay. A switch can be so old if it's taken care good. But in general, so the rail equipment is a very long-term planning process. So you need to plan for 10 to 30 years. This is the best. But very often the political framework gives not this long planning period and are not giving the necessary budgets. Or more importantly, the supplier industry don't have the capacity. So the best thing you could do would be just close the whole net down completely, renovate it 2 years and then it's there. But even if you would do it, and even if you would put the funding in this, the industry doesn't have the capacity to do it. So you have to do this step by step. And what politics could do is create something like an infrastructure fund, like you have in Switzerland, which works very good, also in Austria. So you have a long-term planning horizon. In Germany, you have only 12 months, and then you have political change. And the supplier industry, they are not increasing production capacities if they don't have the security that there's a continuous investment going on. But actually, they're starting it, which you might have heard by renovating these corridors, which are the most critical corridors. Started with the so-called Bahn between Frankfurt and Mannheim, and from August on, it will be the track Berlin-Hamburg, and then there are 40 more high-speed corridors or critical corridors which will get renovated. So they are working on the problem, but it's nothing which can be cured in 6 months. This is a project over years.
Yeah, and the shortage of skilled workers then obviously does not help at all.
No.
But it seems that your technology can help operators deal with this challenge.
Yeah, it can make make the whole maintenance process more efficient. Yeah. So in Germany you have 2.5 million of minutes where switches are not working. So these are almost 5 years cumulated.
Wow, in 1 year. What? No.
Yeah. So if you put the times together, because if there's what happens if there's a malfunction, the whole track gets closed and the trains are getting rerouted, and then people have to go out and check the switch and also repair it. And if you don't have enough people, it takes time till they're out of the track, and then they have to check it, and then they might change some component, and it might not be on the warehouse, it needs to be ordered. So this might take time. And of course, the less people you have to go out. So what you want to avoid, avoid a breakdown. So what you want to do is you want to know exactly at every minute what is the condition of your switch. And if you see there might be a breakdown, you want to send out service teams in advance. And there might be some switches which are very stable and work very good. And you say, okay, I see this switch is fine. I don't have to send a team in a regular interval to this switch. I rather take it and already put my resources on a switch where I see this might have problems in the next 3 months.
Yeah, that is the benefit of doing maintenance predictive, right? You invest a little bit, but then in the long run, you prevent like really critical failures where once the thing breaks, it would shut down the track for a longer period of time, causing even more disturbances. So,
yes,
interesting.
Yes, and also, of course, if you start to calculating all the delay minutes of the passengers in the train, and the damage, economic damage, of course, it's worth a lot to do research.
How do you prove the effectiveness of your system to potential customers? What metrics matter most to railway operators?
At the moment, we have a scientific project together with Fraunhofer Institute and the Federal Railway Agency, Eisenbahn-Bundesamt. And of course, as you can imagine, it takes some time. It's a 3 years project. To prove what kind of digital systems really work to make it efficient. And at the end, the goal is to reduce this 20% delays because of switch failures significantly. You will never reduce 100% because there are failures you cannot foresee, but you can reduce a significant number.
Interesting. Is it the Fraunhofer IML for the logistics department?
It's Fraunhofer IVI. There's a deep knowledge about the tracks, and it really makes sense. So everybody has to work together here. Even the different supplier of sensor technology, there should be an exchange, and then you should see what is the best solution for which component.
Yeah, it's really interesting that you have the operators, the suppliers, researchers, and the government all pulling together on to make this to make the system better in general.
Yeah, it's a very in Germany you say dicke Bretter bohren, so you really have to drill deep down. Yeah. It's long term, but it's also very rewarding because you can really make an effect. You can really improve the system railway, which I think it's on the one hand an old system, but it's a system which is very important going into the future.
Yeah, as you mentioned, it is the most sustainable and environmentally friendly way to move a lot of people at the same time.
Yes, if it is electrified, but it's a most energy efficient way of mass transport because you have steel on steel and you hardly have any friction. So if you imagine a car, to push a car which has a weight of 1.5 tons, you cannot push it with one finger. But if you have a wheel set of a train which is just on the rails, and you can push it with one finger and it starts to roll.
Really?
Yes.
I have to try that next time I'm at the station.
You have to find a wheel set,
okay.
and a track where you can push it.
You mentioned that regarding the investment, you are also looking to Austria, to Switzerland, where they have different approaches in infrastructure investments. What lessons are you applying to your European expansion strategy?
There's a very tight, let's say, exchange between Germany, Switzerland, Austria, between the professionals, the technicians, but also between France. So there are certain conferences where it's an exchange, and we're talking with all of these people, and of course they're looking very careful what we are doing in Germany.
And can you talk a little bit about your future plans?
Yeah, of course. So we want to. So our home market is Germany. We really want to improve it. We want to reduce the Weichenstörungen, the breakdown of switch and crossings, and we want to improve it. And then we look at other European markets, which is UK. We have already discussions with France. We are in discussions with Austria and Switzerland. By the way, it works much better, the railway network, but they also have other circumstances there. But still, they have the same problems, and you can still improve it. And also in the US, the freight lines are very interesting. Also, passenger traffic in the US is growing. And the Asian countries are also interesting markets. China is a very interesting market.
What role does artificial intelligence play in your predictive maintenance algorithms?
I think it's a very important role which is played, and it gets more and more important as the technology improves. But you have to make sure that you really understand what is going on the track so you can train the right models. And it's very complex because if you see a car sees a stop sign, and the stop sign is always the same. But on the track, on a switch, no switch is identical to another switch. There's a difference in age, there's a difference in radius, there's a difference in underground, there's more heat on the one and more snow on the other. Everything is different. So you really have to identify the key parameter. And it's not only that you see the moment when the switch breaks down, you really want to come from a condition-based maintenance to a predictive maintenance, and as early as possible.
And where do you see railway IoT technology headed? What developments are you most excited about?
You have developments in the infrastructure, and you have developments on the rolling stock, and both sides are very interesting developments. So, for example, rolling stock. Do you know with how much speed two cargo trains hit each other? Nobody knows it, but if it's too strong, there might be a damage. Yeah, what is a solved problem in rolling stock is really monitor the doors, that it's really everything is closed. In infrastructure, there's a lot to do. For example, the catenary, so the electricity lines. You know, if there's a short circuit somewhere because a branch fall on it or whatever, the track workers still have to go along the catenary and look, where did this happen? And you know, what you want to have, you want to know exactly where's the spot so you can send the teams and they can repair it. Another problem is also the network. I mean, you know it. It's hard. You have a radio cell, and a train comes with 500 people or more in, and it goes for seconds through the cell, and then it goes in the next cell, and everybody wants to have high-speed internet. You know, you want to continue working with your cloud, and it should all work seamlessly. And of course, also for our technology, the network is very important. So there's still a lot of challenges to be done.
Yeah, it'll be exciting to see where the digitalization efforts in this segment will lead to in the next years.
Yeah. Yeah. I mean, there are studies which say it can increase rail traffic by 30%, the digitalization, all the different stuff, without increasing the network.
Okay, wow. I would have thought that the infrastructure wouldn't be able to handle that at the moment. But you say that could be done?
Yes, it has to be done.
It has to be done.
It has to be done. It also, you also want to add infrastructure, but it's more an organizational issue, and it's also getting the infrastructure renovated, and it's like a roof. We are our roof leaks at the moment, so now then it's worse than keeping the roof always in the best condition. This might be more expensive in the short term, but it's much, much cheaper in the long term for sure. And this is what we're seeing now. We just have to catch up.
Absolutely. What's next for AXO Track? Any exciting new developments or partnerships you are allowed to share with us?
We are just in development mode. So we are very comfortable, quiet, sitting in our office, developing, we are very busy until end of September to bring sensors on the track. As you can imagine, it's not so easy. It's one point you need to get installed very quickly. You don't want to disturb the train traffic. You just go out, mount the sensor system, and then go off the track. And so this all has to be organized. So we move forward step by step.
Very nice.
No excited announcement at the moment.
No, but it is a new technology, and you are rolling it out. So that is terrific. The last and most difficult question: what song would you put on the soundtrack of this episode?
On this episode,
of
course needs to be on topic.
Yeah.
This would be "Railroad Man" by Eels.
Very nice. Thank you. I will put it on. We have a playlist on YouTube and on Spotify, and it is growing. And so it is now.
Great.
It is
I love this
very
song.
nice addition to the compilation. Thank you so much.
Thank you.
Oliver, it has been a pleasure having you on the show. Thank you so much for sharing your insights. I'm really excited to see where your company and your technology is going. And I wish you all the best of luck. It was really interesting to learn how IoT sensors can transform railway switch maintenance and what it all impacts with one little piece of technology for such a critical piece of infrastructure. Thank you so much for sharing all your insights and your knowledge. And I hope to have you again on the show, maybe in a couple of years.
Looking forward to it. Yes.
Thank you so much for listening to We Talk IoT. Until then, keep innovating and stay connected.